Good morning, and this morning we're going to review the areas of data preparation, tidying, cleaning, and if you can do all the things that are in today's lecture, then you're in pretty good shape for this course. There are many more features of dplyr that we're not covering here. We're just covering what you need to know in order to do the primary purpose of this course, of course, which is statistics, which we'll be getting to. But as any scientist or researcher will tell you, you do spend more time on data preparation and cleaning and tidying than you do on actual statistical analysis. And I would say the ratio is probably as high as 3 to 1 on the amount of time you spend. So it does behoove us to learn this. And as you'll see from our textbook author, and this is one of the reasons why I like this book, is that she takes this part very seriously, and each of the chapters that we'll be covering does include a significant portion dealing with data preparation and cleaning. Okay, so let's go over this. A lot of this you've seen before. A few things may be new, and you can see I have some other programs open, and I have some other variables already in my environment, so just ignore these. This is other work that I'm doing that I don't want to erase right now. Okay, so we begin with dplyr, and as I've mentioned to a few of you, generally good practice to put your library statements at the top altogether. I compare them to the ingredients of a recipe, so if your code represents your recipe, then you put your ingredients at the top. So we're only going to use one library today, which is dplyr. Okay, and we're going to read in our heart data, which we've done many times before. You see over here 303 observations of 15 variables. We can use the call names function to look at the column names, and you can see there are 15 of them. They are all capitalized except for diagnosis, and words are separated by underscores, so the author of this data set was following this naming convention, and so we want to keep that in mind. For example, if we want to run the table function on the thalassemia variable, we want to make sure to capitalize thalassemia because R is case sensitive. Okay, and so we see that the values are 3, 6, and 7. Only 18 have a value of 6, and there are 2 that have a value of question mark, and those we don't want. And we want to follow the R convention of using NA to indicate missing values, not question mark, and so we can use the NA underscore if function on the data frame heart, and wherever it comes across a question mark, it replaces that with an NA. And this will actually do this with to all the fields, not just thalassemia, in case they use this anywhere else. And so we're pretty confident that we don't want question marks in our data. Okay, and so we run that. And now if we do incidentally, if you haven't discovered this, the up arrow key is one shortcut that you can use to review past statements in your console. Okay, so what I want to do is look at the table function of heart $thalassemia, which I did 2 steps ago. I want to do that again, but rather than type it out, now I could go up to line 7 and run line 7 again. That's another way. But I could also hit the up arrow key. If I hit the up arrow key one time, it gives me back the thing I just ran, which I don't want. If I hit an up arrow key a second time, it takes me back to my table statement. So this is one way that I find quite useful to save some typing. And of course, that is the table of the original heart data. I changed it to heart 2. So what I want to do is I can actually edit from within my console put the number 2 there. Okay, and so now I see the question marks are gone. It does not report the NA values. Some functions report NA, some functions don't. That is a bit confusing. Table does not. Unique. Actually, let's use our up arrow key shortcut, okay, to recall our previous statement. If I put unique around that, it'll give me the unique values from my, oh, and I don't want table. I just want unique heart2 thalassemia, okay. So the unique function does give me the NA, but the table function does not. Okay, so that's a bit of a quirk of how some of the R functions work. Okay, moving on to line 11, and you'll notice I put a blank line in between every line. It's not required, it's just I find it cleaner and tidier to look at to do it that way. There's no limit on how many lines your program can have, so it doesn't really matter having blank lines in there. Okay, so in line 11, we're going to review the pipe feature, and I am chaining together 2 statements, which many consider to be a bit tidier, and it saves a little bit of typing. And as we'll see, our textbook author does this very, very often, so it is good to be familiar with this style of writing a line of code. So in line 11, I'm going to overwrite heart2, and I'm going to assign that the value of heart2, and then I've got the pipe here, and I'm going to filter age is greater than 50, and at the same time I'm going to select 3 variables. Okay, so remember, filter operates on the rows and select operates on the columns. So when I run line 11, I'm expecting to have only 3 columns left in my data instead of my original 15, and I'm also expecting to have fewer rows because I'm saying age is greater than 50. So let's see if that is the case. And if I look over in my environment window here, I see now I only have 209 observations and 3 variables. So that worked. Okay, line 13, we have filter again. This is how you use filter if you aren't using the pipe structure. Okay, and so here we are overwriting heart2. We're filtering on heart2, and here we're saying the age is not equal to 63. Okay, and this is not a particular example you would likely to use. We're going to get rid of our 63-year-olds from our sample, but I've just put it in here just to illustrate the not equals function, which in R uses an exclamation point followed by an equals, which a lot of computer languages do this, but in school you may have learned that not equals is like that, but that doesn't work here. Okay, exclamation point equals. And so here we should expect to see that 209 observations reduce by some amount. And indeed, we see that it drops down to 200. Okay, now we had the head function as one way to look at the data. Look at the first 6 rows of the data. And so here we see age, sex, and thalassemia score for the first 6 rows. Now, you may want to look at a specific row, not just the first 6. And so the way to do that is, well, one way to do it that you may find easier is to just view the data, which is, if you click on the variable in the global environment, a view window pops up, which is sort of like a spreadsheet, and you can scroll and you can sort the data by clicking on the name of the variable. You'll notice in the console, view heart2. So when I click on the word heart2 over here on the right, it actually, that equates to as if I had typed view heart2. Notice the capital V, function names are also case sensitive, and so even though most functions in R use lowercase, view uses uppercase, which is a bit unusual, but you don't often type the word view in any case because you can click over here. All right, so that's one way to look at individual rows, but an alternative, maybe we'll use this a little bit less often, but it's a good way to introduce this idea of bracket notation. So R refers to specific rows and columns within a data frame using brackets. So in line 17, what this does, it will print out to the screen row 47. So the order is row, comma, column. Row 47, columns 1 through 3. You can specify a range with a colon. Okay, so row 47, columns 1 through 3, and that's what we see on the screen in the console. R gives you a little shortcut, which is that since there are 3 columns, if we're interested in seeing all the columns, we don't actually have to type 1:3. We can just leave that blank. So 47 comma will give us the same result. Okay, and this colon structure works on both the rows or the columns, and so in line 21, we're printing out rows 50 through 55, all columns. So let's see what that does. Okay, we see that works too. All right, so these are some alternative ways to look at pieces of the data other than the view window and other than the head and tail functions. We can use the same approach to actually modify a value within a data frame. And so, for example, thalassemia is the 3rd column. And so in line 23, we're saying for heart2, row 2, column 3, change that value to 9.9. All right, and if we look at the head, oh, here we go, line 25, if we look at the head function, we see row 2, column 3 is now 9.9. Okay, so sometimes in the process of cleaning or tidying data, there's just 1 or 2 data values that are wrong in some way, and the easiest way to fix them can just be to do it by directly hard coding the correct value in. Okay, and so we're going to leave you with the mutate function, which is how you change a value, how you change all the values in a table at once. Okay, and so the example I'm going to show you is we're going to create heart2 or overwrite heart2, and we're going to use the mutate function on the data frame heart2. We're going to create a new variable called age months, and that we're going to set that equal to age times 12. And also in this mutate step, we're going to set the value of thalassemia to null. And when you set a value to null in a mutate step, it's the same as dropping it. Okay, and so what I expect to see when I run line 27 is a new variable called age months, which is 12 times age, and the thalassemia variable to disappear. So let's see if that actually ends up being the case. So let's look at, and indeed that is what we see. Age, sex, age, months, thalassemia is gone. All right, and so that is how mutate can be used to generate a new column. It can also be used to perform an operation on an existing column. So let's just do one more quick example. Mutate, let's say sex equals sex plus 1. All right, so instead of 0, 1 for male, female, let's do 1, 2. Because there are some data systems that do it that way, so maybe you like that better. So in this case, we're not creating a new variable, we're overwriting a variable. And let's see what that looks like. Okay, so now the values of sex are 1 and 2 instead of 0 and 1. Okay, so select, filter, mutate, head, tail, bracket notation, call names. If you can keep all these in mind, you're in good shape for this course. Thank you very much. Have a good weekend and a good holiday.